So get that definition down.
So this was what we just looked at on our data. We had a number of cars, recorded frequencies, and relative frequencies. Let's make the histogram to go with it. So we are going to, I'm just going to do this one by hand. It's not a very big one. If you're making a histogram, you should title it something. So what should I call this one? Number of cars, cars per household, something. Okay, if I'm making a frequency histogram, then my vertical axis is my frequency. My horizontal axis would be my different classes, which in this case is number of cars. When I looked at my number of cars, was that discrete or continuous data? That was discrete. We listed them out. So if it's discrete, we can just list them here, space it evenly. If it were continuous data, like if we had decimals, then we would have to give a range of values, you know, from 0 to 1, and then from 1 to 2, and everything from 2 to 3, and so forth. But these were discrete, so we can just list them out. When we draw this histogram, what we're actually going to do is center our bars over the number that we're graphing. So my frequencies went from 1 to 22, so I'll just count by 2s. Okay, so 0 had 4 cars. So what you're going to do is take a rectangle with a height of 4, and you're centering it over the 0. So it starts and it ends halfway in between our 0 and 1. 1 had a frequency of 13, so we have to make these touching. So it'll look like this. 2 had a frequency of 22. 3 was at 7. 4 was at 3. And 5, we only have 1 car. 1 household. The example also asked for the relative frequency histogram. We can make it if you guys would like, but let me just ask you, what's going to change when I do a relative frequency histogram? The y-axis. It's not even going to change the bars themselves, it's just the labels over here. I'll have from 0.08, or no, my smallest was 0.02, going up to 0.26, so I would have like 0.04, 0.08, and just changing those labels and this to relative frequency. The rest of the picture looks the same. Do I need to draw that for you, or you guys know what I mean by that? Okay. Just another term, the classes are just the categories that I use to group my data. And that's really all you have to write down, but I'm going to give you problems and I'm going to say divide it into classes. So I'm just asking for the groups of data. We use that with discrete data if I have a lot of values. You know, I only was looking at numbers from 0 to 5, so it wasn't a big deal. But if I were looking at 0 to 5,000, I probably would not want to have 5,000 rectangles on my graph. So I might lump them together and do, you know, 0 to 500, and 500 to 1,000, and 1,000 to 1,500, and those would be my classes. Or if you're using continuous data, so if you have decimals coming into play, that would be another situation where you would need to use the classes of data. So I wanted to look at one where we actually had to do that. Remember, you do have all of these printed on your example packet. So the following data represent the time between eruptions in seconds for a random sample of 45 eruptions at Old Faithful. I want a frequency and relative frequency distribution. Okay. We could list out every single possible value here. But this is an example where we might want to do classes. So time, like I said, if you need to, you can include a column to make tally marks if that helps you count them, but you don't have to. Frequency, and relative frequency. Okay, let's make our ranges. If I'm looking at this, the smallest value I see, I've got a 672. And I think that's the smallest one. My biggest one, let's see, 736. So we have to figure out some way to group these to hit everything between my 672 and what, 738, is that the biggest?
That's the biggest one I see.
Okay. So you can divide those. If I don't specify, you can do it however you want. I'm just going to maybe go by tens. So I'm going to start at 670. And I need to end this. We don't have to worry about decimals here, so I'm going to go 670 to 679. And then I'll start my next group at 680. If I ask you for the class width of this, the class width is how far it is from the beginning of one group to the beginning of the next. So this is actually a width of 10. But I don't want to say 670 to 680 up here, because then you wouldn't know to put the 680s with the first group or the second group. Okay, so we're spacing them out like that, making our different classes. Okay, so then we have to figure out how many points fall in each of these groups. So we're looking, you know, how many times are between 670 and 679. So 672 would work, 678, and I don't see any others. So there's a frequency of 2 for that one. Between 680 and 689, I don't see any, so that's a 0. This is where your tally marks could help if you just wanted to go through your list and sort them that way. Between 690 and 699, do you guys know how I'm counting these?
Yes.
If I tell you how many fit in each group to save time, is that okay?
Yes.
Do you know how you would sort them? Okay. So I think we get 7, 9, 9, 11, and 7 if I sorted them. So I kind of cheated there and just gave it to you, but on your own you would have to sort them out and figure out which group they went in. It would probably be easiest on a problem like this with a lot of data to make tally marks. You know, go through 728 is here, 730 is here, 726, and count them that way. Alright, relative frequencies. How many data points do we have? 45. So divide each of these by 45. 2 over 45. 0 over 45 is 0. 7 out of 45, round appropriately. 9 is 0.2. So that's the frequency and relative frequency table like we did yesterday. If I asked you to make a frequency histogram, we could do that by hand. We did the last one by hand. I also wanted to show you how to use your calculator to make those. So if you have a graphing calculator, great. If not, you need to open up your Chromebook and open up that TI app. On the calculator, there are step-by-step directions on page 86 of your book. So if you want to go ahead and open up page 86. Okay. So on page 86, it gives us step-by-step directions for doing this on the TI-84 calculator. So the very first thing we have to do, and I'm going to do it from my computer, I work much better that way. Looking at your steps, you are going to go to Stat. It's right under the delete button. We need to go to Edit, number 1, and we are going to put data in L1. Now, don't do anything. If you have numbers here already, do not delete. It will delete out the entire list in your calculator and then nothing works correctly. If you have stuff entered in your list already, you can go up to the title. So go up to where L1 is highlighted, hit clear, enter, and it takes all of that out for you but keeps the list. So don't use delete, just clear. Now we need to enter all of our times that we were looking at. And I would like for everybody to do this. So here, let me pull those up for you. All right, start entering your times. everything in the same list here. Yes, ma'am. You're welcome. And hopefully when you get to the end you have 45 points. If not, you missed one or did one twice. Looking at that page 86 in your book, we've done step 1. Second thing, it says you hit second and then y equals. You see that takes us into our stat plot menu. So second and then your y equals. Okay, we want plot 1. So just hit enter. And I want to turn it on. So you need to hit enter on top of the on, so then it moves this box there. So raise your hand if you're not with me. Second, y equals. Okay, second y equals. And then we want plot 1, turning it on. And then hit enter on top. Okay. Then this shows us all the different graphs we can make on our calculator. We are looking for the histogram, which it's kind of hard to tell because they're very tiny, but if you go down to type, it is that middle one. And you have to hit enter to select it. This is why I really wanted to make sure everybody put everything in L1. It will come up as your X list. It will always automatically do L1. So as long as your data is there, we don't have to change anything else. So now we can get out of here. So we're going to hit second and quit, which is the mode button. So second and then your mode. That quits and takes us out of this menu. We are going to have to adjust our window. If I just look at my graph right now, my window is not going to show me anything. So let's look at my window options. My X's, we started when we did our frequency distribution. What did I start my first class at? So my X min is 670. My X max, what was my highest class? We ended at 739. My scale, how wide were my classes? 10. So my X scale is 10. My Y's, let's just go from 0 because we're graphing the frequencies here. And the most anything showed up, what was like 11 times. So let's go 0 to 15. Okay. Then let's hit graph. And we have a nice pretty histogram. Yes.
What is that line? Why doesn't it have that?
What is that line in? I'm sorry.
you are giving in invalid dimensions. Let's do this. Let's go ahead and just reset the memory on your calculator if you're getting that invalid dimension, and that will fix anything so that the next time you work, it'll work correctly. So if you got that error message, just raise your hand and I can reset it for you. You're going to hit second.
Wait, is that like the line that shoots across? Because mine's fine at first and shows it.
Do you have data entered in your y equals?
I was
Okay. This is talking about the class million yard. So your x-min would be 670. And your x. Great. And then your x is 739.
I had like
And your x is 10.
Yeah, I got this for Christmas.
Does it do anything different? Good at Christmas.
Okay. Y min I did 0.
What?
Does it do anything different?
And y max I did 15.
I don't know. Yeah. It's just like it shows graphs a lot better and you can like move it.
Alright.
I got it.
Got it?
Does
Okay.
that calculator do anything different than this calculator?
It has color.
Okay.
And you like charge it.
Yeah. Doesn't have that. Alright. Is this okay with everybody? And I showed you where it was at in your books so that you can go there on your homework if you need to make one.
Which is that again?
And it's page 86. Okay. Let's talk, we don't have a ton of time, but I want to get through just a couple more things. Some of these are pretty familiar. Do you remember stem and leaf plots at all? Been a little bit since you've talked about those. So in a stem and leaf plot, your leftmost digit is your stem and your rightmost digit is your leaf. And so then we can set it up. I put an example on here, but we're not actually going to do the stem and leaf by hand. I'm just going to show you what it looks like for the sake of time. The benefit of a stem and leaf plot, if I'm looking at my frequency distribution, I've kind of lost my original data. I had that there were two values between 670 and 679, but I don't know what those two actual eruption times were. With the stem and leaf plot, you could write down all of your original points from those. So for example, if I were looking at unemployment rates, so on that notes handout where I gave you all of my examples, I have this huge example with unemployment rates, and it has each state, and these are all decimals, 4.7, 6.8, 3.2, so forth. If you want to make a stem and leaf plot for that, I'm just going to show it to you because we don't have a ton of time. Your stem is your whole number part. Since the data I had, 3.2, 4.7, 6.8, those types of numbers. So those 3, 4, 6, those are your stems. You have to put them in order from small to large. My vertical bar in this is like representing my decimal. And then my leaves would be, it was 2.8, so my leaf is an 8. You do need to put your leaves in order, and if something shows up multiple times, you have to list it multiple times. So I had 3.2 3 times, so I've got 3 2s there. So you just put them in order. Does that make sense? So if it were like 5.0, you have your 5, you put your 0 here. If it showed up 3 times, you would have 3 zeros on your leaf side. These you can make by hand. If you could make it in Google Sheets, just make yourself a table, put the stem on one side, and type your leaves to the right.
So what if a decimal has multiple?
So your leaf is only the rightmost spot. So if your numbers were like 128, your stem would have to have the 1, 2, and then you would just put the 8 there. Other questions?
Wait, that one's in a decimal.
No, that one wasn't. It doesn't have to be a decimal for the stem and leaf. It can be, but it doesn't have to be.
So like if it's like 3.0204.
Mm-hmm. So if I had data like okay, why is my okay. So if my data were 3.02, 3.04, 3.16, 3.17, then my stems would be 3.0, have a 2 and a 4, 3.1, 6, and 7. Is that okay with everybody? We can also do a dot plot. So probably the last one I'll talk about today. In a dot plot, you put your observations horizontally in increasing order and put a dot for each time it's observed. I'll give you a second to jot that down. Because I don't have a ton of time, I'm stopping here. All I have left, I was going to do an example of a dot plot, and then I had 4 terms that I wanted to go over. So if you guys don't mind, I will make like a 5-minute video to wrap this up and post it. And then tomorrow you just need to watch that last 5-minute video, and then the homework from both 2.1 and 2.2. It'll be a work day for those. I'll go ahead and write the homework up here as well. And I'll probably have that video up by the end of the day if you want to go ahead and watch it. It'll be brief.